So our topic for today is about the beam, and there are very important things that we have to understand here in this specific engineering structure. No, so as a review, we have two kinds of in general we have two kinds of beams that we are trying to solve. One is statically determinate, no, and the other one is indeterminate. Anong ibig sabihin nun? Yung may mga beam na madali lang kunin yung mga force tsaka reaction, ang tawag sa kanila ay statically determinate. And there are beams that are very difficult to find the forces and the reactions because we have more unknowns than the equations. I'll repeat, no, if you have more unknowns, no, than the equilibrium equations, now we will have some problems because normally the rule is one equation for one unknown, right? So, for example, to illustrate what I'm saying, for example, can you solve this? 5a plus um, 5 now equals what? 20. How many unknowns do we have? Ilan yung unknowns natin?
One.
One, no? So, we have one equation, one unknown. So, how do we solve that? 5a equals 20 minus 5. So 5a equals 15. So a equals 15 over 5. Then a here is what? 3. Pero no, the other story is this, no? 5a plus b equals 25. Can you solve that? Can you solve this in this given equation? Only this. You cannot solve this because we have only one equation, but we have two unknowns. And that is exactly what is happening in these statically indeterminate beams. No, there are more unknowns, no, variables than the available equations that we can have, and these are in the continuous beam, beam fixed at one end and simply supported at the other end, and fixed beam in this configuration. So what we can only solve right now as far as our subject is concerned, eto, no, simply supported, overhang, and cantilever, and that is what we are going to talk about. So today or this morning we are going to discuss how do we really solve this engineering structure of beam. How do we solve the reactions? How do we solve the forces? So before we go to the topic, I mean for the sample that we have in the lecture, let me flash the other supporting lectures. No. So here is the beam. Now, for example, we have a beam. As I told you, there are kind of fixed procedures that we have to follow. One is we have to first draw the free body diagram. And what is the free body diagram? Free body diagram of a certain engineering structure is composed of the available forces, no, mga loads, and ito drawing mo rin, you have to draw the reactions. Now, yung reactions, makukuha mo yan normally beneath the structure. Bakit beneath? Where is the reaction dependent on? Saan ba depende yung reaction class? Para malaman mo yung reaction, kung vertical o horizontal, saan siya nagdidepende? Any idea? Ano tong mga to? What is this? How do you call this? Anong tawag dito, class? Jude, anong tawag mo dito?
Support.
Support, no? So if you know the support, you will know the reaction. But if you don't have any idea of what's going on with the support, you will be lost. No? So for example, here is a support, no, like a triangle. So we know that it has a vertical and horizontal, no, constraint just to be fixed. And here we have a support because this is a load, no, meron to, no. This member has a weight. So eto, yung bigat ng beam susuportahan dito ng roller, no? Yan. Pero at the horizontal, no, left and right, we don't have any support. We don't have any reaction because these are rollers, and rollers what can roll to the left or to the right, no, yeah, frictionless. No, normally it is used in the frictionless analysis. So we don't have constraints on the left, on the right, and the right because it can freely move. No, it can freely move. So in that case, we can plot the reaction, and that will help us in the analysis. For example, here, no, we have this and we have this, then also like this, no. So dito, anong meron tayo rito? Siyempre may weight to supported this, and here may reaction. But here we don't have, no, we don't have any reaction because it is not reacting. There's no support, there's no reactionary force that tends to counteract the beam in this case. Now, so let us go immediately in this particular example so that we will be more clear in this topic. No? So, for example, this our beam. This beam, no, kinat ko lang yung first, hindi ko na ilagay. So, this beam, let me choose another light pen. No? So, ito yung beam. Meron niyang triangular support, and this one is with the roller. Again, so if this is fixed, the weight, no, of the beam will react here and also somewhere here. Then here is the roller, no, roller yan. It can move freely to the left and right. So we don't have a reactionary force that is composing on the left and rightward. Wala, no? So yung weight nitong beam on this particular portion is just eto, no, pababa. So ika-counter siya ng pataas. So ito 'yon, no? Maliwanag 'yan, no? So it's clear. Now, this is the free body diagram, and as you can see, we have two forces. One is here and one is here. So if you can translate your pictorial drawing or graphical drawing into this portion, because you know the reactions now based on the support, you are good to go. Okay? So what's the next? Now, in general, what's the next thing to do? So the next thing to do is you have to analyze all the forces going along the vertical. When I say vertical, no, going up and going down. Ito yun, no? So those forces must be cancelled out with each other and should be equated to zero, must be equal to zero. Kasi nga, ito ay, anong principle yon? Equilibrium, no? So if it's in equilibrium, meaning balance, it's not moving, no? So if it's not in equilibrium, it's moving, no, everywhere, side, left, top, right, no? But if it's not moving, it is static. So the forces, meaning is balanced, all the forces are canceled out, so its summation is zero. Same thing is going through with horizontal. All the forces going to the right and all the forces going to the left must be canceled out so that it will become zero, no, in the principle of equilibrium. And the same thing, the third one, the moment. What is the moment? Moment is the phenomenon, no, that tends, no, the force that tends the structure to move, no, in a rotational way, no? So there's a force and there's a distance concerned, no, from that reference there's a distance. So the body could move, no, going here, what's this, clockwise, or in that other direction, no? If the force is going upward, so it's going here in this direction, that is gonna be like counterclockwise. So our sign convention, counterclockwise is what? Positive, and clockwise is negative. No? So yun yung pangalawa. No? So we have to also have the skill necessary to identify whether it is statically determinate or indeterminate. So we don't have to discuss this because this is another domain. No, there are more forces than the available equations in the equilibrium. So we're not going to tackle this. We are going to concentrate more on this. No? So those are the things. Now we have to determine the internal forces. And if I may ask you, what are the internal forces? So the internal forces normally based on the one that we solved last time. No, I mean I think last meeting. What is that day? Wednesday. No. So we are solving the shear. Ito po yung shear. This is the shear. No, the one that is designated with the V. No, vertical shear. And the other is this. No, yung moment. Kaya merong ganyan. Meaning it could twist. No, it could rotate on the left or right. Of course, kasama din tong mga yung mga axial forces external, no? So this is external, no? This is a right or left as a reaction, and this is internal, no? Internal forces. And what is the significance of these two forces? The internal forces should balance, no? Should counteract the external once you cut. So how do you cut? Yeah, you cut here, no? You cut it here. So you will have the internal forces. And the internal forces should balance the external. That is the way to analyze. Now, so as you can see here, this is supported, fixed, and this is the roller. Then if you cut it somewhere in the middle, you will have a vertical shear. No? So ito yun. Kaya nga V, no? Vertical shear. And this one is going down, that's going up. Now kasi shear nga eh. Di ba? If I put in the 3D so that you will understand, I will cut here, no? Parang I have a knife, I will cut here, no? So if I cut here, it will have two kind of section. Ilagay ko lang yung section, no? Tapos ito rin yung isa. Yan, no? So ito yung shear, no? Para kang nag-cut ng spam or ng bread. So ito yung shear, no? Ito 'yon. One is going up. Ito, one is going down, no? At the same time, meron ding moment. No, if you cut it at the middle, there's a moment, no? There's a moment going, what is this moment? Counterclockwise, and there's a moment going clockwise, no? So that is the way we do it. Another point or another way of interpreting this, no? As I told you before, when the beam bends, no, for example, there's a force here, no, when the beam bends, no, so there's a tendency that it will bend upward or downward. So if the bend is towards up, no, sabi niya sag, no, ano yung sag? Ito, nakalundo, nakalaylay, no, sag. Pag lumaylay yan kasi may force dito, meaning the curve is going up, no, the curve is going up. Ano yan? Positive. But here, for example, the force is here, no? Either here or dalawa dito na puwersa. Ang tendency niyan ay ito ay magiging down, no? Yung curvature is down like this. Yan. So the curvature is going down, or in English, ang sabi nila, the term is hog. No, hugging. We are not so familiar with hugging. But for native English speakers, they know this, no, hug. But for us, no, if you are Filipino, we are non-English speakers, ganito na lang, no, para madali, no, para madaling tandaan, going upward ang beam, positive. Pag nag-bend downward because of the forces, no, ito ay negative. Okay? So yun yung mga mga kailangan na basic knowledge. Now, we will have an example here. The example at the outset or at the beginning, we're given some data. No? So, what are those data? If you see this, no? Pasandok mo ako lang. Padala dito. So, if you see this, chicken nuggets. So if you see this, it has no value, no. But on the succeeding slides, we were given values so that we can analyze this. So what are the values here? So as a reiteration, we have a simply supported beam. We have here a fixed support, and the other is roller. So we were able to identify that here the reaction is vertical and horizontal now because it's fixed. Here there's a free movement of rollers going left and right, so we don't have reaction. The only reaction we have is this now. The weight of beam with respect to this point, no, is going down, so we have a reaction that is going up. And aside from those originally loads that we have, so we have a 15 kilonewton, which is 2 meter away from the left support, and then another 6 kilonewton away from about 4 meters, no, 4 meters away from the left support. Meron yan, di ba? And here, then another 2 meter, we have a reaction B because of its roller. So how do we solve this? Can we solve this together? If I say how do we solve this, no? For example, I want to analyze the summation of forces along horizontal x, which is positive to the right, left to the negative, must be in equilibrium or equal to 0. So what are the forces? What are the forces involving the horizontal direction? So the forces is what? HA, no? So HA is going to the right, no? Equals 0, meaning summation of forces along X. There is no other forces involved. So we know that this HA is a reactionary but zero member, no? Wala siyang value, no? Kasi wala namang ibang kumukontra. There's no counter acting forces with respect to horizontal. What about the vertical? How can we have the vertical? So we can have the vertical. We could have here, no? We can have a moment with respect to A, no? Summation of moment with with respect to A. So how do we do that? The summation of moment, no? Let me use this summation of moment, no? Clockwise positive with respect to A is what? So ito yung pivot point mo. Ano yung mga forces? What are the forces and the distance involved? So look at this. So here, no, yan. No? So 15 kilonewton, no? Anong mangyari diyan? Negative, di ba? Counterclockwise, clockwise, no? Clockwise. So negative 15 kilonewton times 2 meter plus i-add natin pero negative uli, no? Clockwise in the direction of the clock. So the force is 6 kilonewton and the distance is 4 meter. What else? There is this reaction of B, RB, no? So RB, so this one, no, is reacting like this, no? With respect to A, it is counterclockwise, and counterclockwise is positive. So the distance is what? 6 meters. So the question is, can we get something from the equation of the moment? So let us try this algebraically. 15 times 2 is negative 30 kilonewton meter. And then this one is also negative, right? Because it's going down, and then it is clockwise. So negative 6 times 4, negative 24 kilonewton meter plus RB 6 meter. So all we have to do, because it is equal to 0 in equilibrium sense, so we have to put this on the other side of the equation. So 30, 30, and 24, how much that? 30 plus 24, 4, 5. Now 54. Are we right? Are we correct? So 54, negative 54. This whole thing, this whole expression on the left side of the equation is negative 54. And we're going to put that on the right. So ang mangyari dyan ay RB equals 54 over, i-divide natin siya ng 6 eh, na 6. So ilan yan? How much is this? The reaction at B is how much? 54 divided by 6 is
9, sir.
9. Now, sir, di ba meron tayong 9 sa RB. So, 15, ito ay 15, ito ay 6, ito ay 9. No? So, tingnan nyo, by just observation, no? Pure and raw, no? Observation, ito ay 9. O, ilan na lang to sa A? Ito, 15 plus 6, ilan?
21, sir.
21. O, ito, 9. O, ilan? Para maka-21 ka, ilan?
12, sir.
Kailangan mo ng 12 na para maging balance. So, tama, no? Ayan, no? Di ba? But, we can solve that in a summation of forces, right? That is purely observation. But we could solve that in the summation of forces, no? So, let me use this, no? Summation of forces going to the right, going to the left equal, ay, tapos na pala tayo sa right and left. Vertical, no? Going vertical means up and down. I erase this. So here, no? So, oh, summation of forces along the vertical, meaning going up and going down, equals 0. So look at this. We have RA. Where is RA going? Upward. 15, downward. Minus 6, downward. And upward is RB. We have solved yung RB. Ano ba yung RB natin? Ay, ano bang na-solve natin? Ano bang na-solve natin? Sorry, nawala ako. Ang na-solve natin ay 9, right? Yung 9, RB. So, plus 9. Okay, ang mangyari dyan, summation of forces along vertical equals 0. Ito ay RA equals what? Lilipat din, 15 plus 6 minus 9. No? So, 15 plus 6 is 21 minus 9. So, this will become 12. Very good. No? So, RA equals 12. No? So, ayun. Okay? So, at this point, it's very clear. No? I think you can have this. You know how to solve this, right? Walang problema dyan. Ngayon, ano yung next natin? Look at this. Up to that point, everybody can do, no? Even high school. But the next skill, the next knowledge that we have to know is the shear and bending moment diagram. Nasaan yun? You know, we should be able to draw. Draw, no? Mag-drawing tayo or illustrate. The shear and bending moment. And that requires a practice or skill, no? And that's gonna be your final exam, no? So, sabi ko nga, mag-aral kayo mabuti, no? Kasi niregalo ko na lang yung midterm sa inyo, no? Para makahabol-habol, no? So, but this one, I really need your analytical skill, no? So, we start with the shear diagram and then bending. How do we draw the shear? We can only draw the shear if we are going to analyze the internal forces. That's why last time when there was observation from the associate dean, no, si Dr. Gia, yun ang inuna ko muna, yung internal force. So how do we analyze the internal forces? We can only analyze the internal forces if we're going to cut the member, no? So we start with the left, no? Ang pag-analyze ay galing sa left, then we cut the member, no, before the next load, no? Tingnan niyo to. So here, what I'm saying is this, no? So this the load, another load. So we have to cut. No, we have to cut. We have to have some cutting plane, and then cut this, and then we should analyze. So go back here. If we cut here in the right side of the 12 kilonewton, no? Because we already analyzed that this is 12 kilonewton. On the right side, as the right side before the next force, we cut it. We cut. Now, when we cut, pag hiniwa natin yan or tinagpas natin yan, there will be a vertical something like this, right? No, ito ay V. Now, anong V? Vertical shear. Eh nga, bakit pababa? Eh kasi counteract siya, no? Again, the internal forces should balance the external. Ulitin ko, no? When we cut, the internal forces, mga puwersa na napapaloob dito, no, sa member nito, sa mga fiber nito, should counteract the existing external, no, in this case 12 kilonewton. So how do we draw? So we draw here, we draw in the thing here is how do we start to draw the 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 shear, no, shear diagram. Okay, so how do we start to draw? Look at this, no? So this is going upward. So this is going upward, no? So this is going upward, and it has a uniform force, no? Until to until the next, no? Until the next portion. So this one, no? So ibig sabihin, ang puwersa na ito ay 12 kilonewton. Ayan, no? So going upward, ito 12 yan, no? By scale. So 12. Kailan lang siya hihinto doon kasi may panibagong may panibagong scalar value, may panibagong value na tayo, no, naging 15. So ganto, going up, and then we will have horizontal. Naintindihan ba? So yan ang pag-drawing ng shear. Ito yung shear, no, ito yung 12 shear, no, 12 shear, kasi binabalance niya nga, no, binabalance niya yung external forces. Now how about the moment? Tingnan niyo yung moment, class. Ano yung moment natin, no? So yung moment natin will start also in this case, no? So in this case, so eto yon, no? Ito yung moment natin na mangyayari. Then we will have to plot until that portion na second, no? Okay? So paano mo nalaman yung moment? Ano yung value ng moment, class? What is the value of moment at this portion? A. Ano yung value ng moment sa A? Ano yung value ng moment, summation of moment of A? Clockwise, no? Negative. Counterclockwise, positive. Ano yung moment, class? Force, no? Diba? Force times distance. So 12 times 2. Diba? Eh, no? So all this constant slope is yun, yung moment, no? Kasi 'di ba magkakaroon nga tayo ng couple of moment, 'di ba? So ang sabi natin, couple of moment, if I may put here, yan, 'di ba? So this one going up, 'di ba? Going up is this, no? So 12, 'di ba? Ito. Going here, counterclockwise, halimbawa, negative 12, 16 kilonewton times the distance, no? So force times distance, 'di ba? So yun ang moment yan bago makarating dito sa another load. Before you reach the 15 kilonewton, there's a moment happening, no? So, this one is, ano to? M, no? Plus M equals 0. So, ang moment na nangyayari dito sa portion na to ay M, lilipat mo lang to sa kabila, is 24 kilonewton meter. Di ba na-take up na natin yan? How to find the moment, how to find the shear, no? And how to find the force. So we have 24 kilonewton meter. That's why we have this, no? 24, not 24. I believe na susundan nyo ang mga yan, no? So maliwanag, no? Kung saan ang galing yung 24 tsaka 12, di ba? Yung 12, ito yon. Yung moment is force times distance at a couple, no? Meron siyang couple of forces. So 12 times 2 is 24. Okay? So now, anong next natin? Ang next natin is dun dun sa mga existing external forces. So in that case, 15. Now dito na tayo sa portion ng 15. What is happening in 15 kilonewton? So dito diretso 'yan, meron siyang 12, no? 'Di ba? Papataas siya, then ito 12. Ito naman naka-slope kasi pag moment, mga slope 'yan eh, no? Ulitin ko, pag mga moment, mga slope, hindi lang sila magi-slope pag zero. No, halimbawa dito wala namang force. Pag walang force na nangyayari, zero 'yon, no? Pero as long as there are forces, etong shear diagram ay rectangular, no? Rectangular. Ito namang moment ay naka-slope, no? Ito, naka-slope siya diyan. Pag wala siyang slope, ibig sabihin wala siyang force, zero siya. No? Now, we go to the next, no? At the point of 15 kilonewton. What is happening in 15 kilonewton? So arbitrarily, you have to cut, no? Kasi tapos na tayo rito, eh, no? Tapos na tayo diyan. The next is somewhere here, no? Anywhere here, we have to cut. Arbitrarily, we will designate a distance, na say x, no? Kasi hindi naman natin alam kung saan tayo nag-cut, eh. In between the this point, no? It in between this point and the next point, we don't know exactly where we are. So what's happening is we will designate that with the variable x, no? And then we will have the calculation of shear. No, ito yung shear, no, V, vertical shear, and then ito yung moment. Sa dalawa lang yan, no? Pag meron kayo nakita na ganito, vertical shear, ito naman moment, VM, no? So ano nangyayari diyan? So the force is going down 15 kilonewton, then the distance is this, no? So 12, sundan natin to, 12x plus ito. So if we are going to analyze this, no, on this case, no, ito yung point natin, then this is the distance. So 12x plus 2, no? So yun ang ano natin, no? 12x plus 2, then 15 to minus 15x, no? So yun ang equation natin. 12, no, ito yung 12, no? So ito yung 12 kanina kasi nandito tayo, 'di ba? Sa portion na to, 12. 12 then x plus 2, no? Kasi yung 12 ay nag-aak hanggang dito, no? 12 dito. Yan. Then x plus 2, no? We have this x plus 2, then minus ang kabila naman niya to balance is 15. Ano 'yun? Ito yung 15. The force tsaka yung distance, no? Minus 15x, no? Hindi natin alam, no? So, yun ang ating equation. So, para magawa yan, no? Ano yung mangyayari sa 12x plus 2 tsaka minus 15x, no? 12x plus 2 minus 15x equals 0. Paano to? So, ilan to? 12x plus 24 minus 15x. Ano sunod? Ilan to? 12 minus 15.
Negative 3. Next po.
Ilan? Negative
Negative 3.
3x. Tapos yung 24. Ilan yung 24? Tama ba yan? 24. So, kung negative, no? Mag-negative siya, di ba? Negative 3. So, dapat maging negative 8, no? Negative 8 ang kinuha niya, no? So, i-check natin muna. So, basta going down, no? Going down siya na meron siya dito na ano, no? Na negative 3 na force, no? Negative 3 na force na binabanggit, no? Para mabalance. So, negative 3. So, ito yon. Then, magiging constant siya, no? So, ituloy muna natin dito, no? Para makita natin yung overall picture. So, pag tinuloy natin yan, no? Ito kasi 24 yung sa moment. Ngayon, pag dumating dito, no? Pag dumating dito, ito ay 18, ito ay negative 9. So, tingnan natin yung moment muna. So, paano tayo makakuha ng moment na 18? O, dito muna sa free body diagram ng portion na 6, no? Dito tayo sa 6, sa portion ng 6, 'di ba? Ito 'yon, 6 kilonewton. Ang mga concerned na sa forces sa free body diagram is there is a 12 kilonewton going upward, and there is a 15, no, at a distance of 2. Then there's a 6 at a distance of 2. And then this one, meron tayong ikakat natin, meron tayong dito, no? Ikakat natin siya. Pag kinat natin siya dito, there's a shear na vertical shear na mangyayari, and there's also this moment, no? So, pag tiningnan natin, ano yung mga paano summation of forces nito? Ilan ba to? 15, 21, tsaka 12. Tama ba yan? So, 15 plus 6, 21. No? So, 21 is going down. Then, 12 is going up. No? So, 21, tama, 15 plus 6, then 12. No? Tama ba? 12 plus 9?
Opo, sir.
21, di ba? So, ibig sabihin, ang ibig sabihin niyan, eto, no? 15 tsaka 6, no? In that case, and then 12, no? So, here, meron kasing dito yan, no? Ang, ang portion na to, meron dito 9. 9 na going up para mabalance to, no? Pero in this case, no, dahil kinat natin dito, meron siyang force na negative 9, no, para i-counteract. Kasi nandito na siya sa right side eh. So, nasa right side na siya, so i-counteract siya ng negative 9 na kilonewton. No? So, ito yon, negative 9 na ganyan, na going down. Para ma-counteract niya itong force na nasa right, no? When you cut it here. So, negative 9. So, itong negative 9 na sobra na to, residual, so, i-straight mo lang. No? Straight mo lang para makabuo ka. Ngayon, we go to the 18. Paano naman nakuha yung 18 class? Any idea? So dito, no? So 'di ba 12 times 2 is 24, no? Force times distance, 'di ba? So 12 times 2 is 24. Ngayon, dito naman dahil kinat natin siya, no? Kinat natin siya, no? Kinat natin siya. If we are going to sum up yung moment, no? Mag-summation nga tayo ng moment about A. Clockwise, positive, no, equals 0, no? Then, ganun din yung ano, yung counterclockwise. So, pag nandito yung moment natin, ano yung mga forces? So, going down is 2, no? I mean, 12, no? So, 12 times 2, yan, negative, di ba? 12 times 2, kaya natin nakuha to, no? 12 times 2. Up to that point is 24, no? Bago sa major. Tapos, ito naman ay, ilan to? Plus negative 15 times, ilan to? 15 times negative 15, ay, negative 15. Ilan to? 15 times 2, then 6 times 2, no? 12 times 2 is 24, then 15 times 2 is negative 30, then ito ay 12, no? 30 and positive ba to? 12. 12, ilan to? 18, saka uh, ilan to? 24. Ito na nga yung 24, no? So, ito yung 18, di ba? 30 may negative 30 plus 12. Tama ba? Negative 30 plus 12. Negative 30 plus 12 plus. Ito negative 30, di ba? Ito yung 12.
Negative 18.
Oh, so di ba?
Negative 8 and 12.
Oh, so di ba negative 30. Ay, tama ba 'yon? 15 times 2 is 30, di ba? Tapos 12. So 10 minus 2 is 8. Negative 2 plus 1 is negative 1, 8. No? So negative 18. Yan. No? So negative 18, no? Pababa. Kaya yan. No? So 24, di ba 24 yan? 2 times 12. Di ba? Clockwise is negative. So, ito rin, no, negative. So, papaganon. No, mas mababa. 24 is higher than 18. So, ito, from 24 to 18, bababa. No? So, ganyan. And so on and so forth. So, ganun lang mag-analyze. So, if we continue the analysis, we will have this. No? So, 24, 18. Tapos, pag tiningnan nyo dito, if you analyze this, no, if you analyze this, so dito, no, wala naman ng puwersa dito, di ba? Wala namang puwersa na rito. So ito, it will just go straight up to the last, no? So ito naman is sloping downward, no, hanggang dito, hanggang mapunta siya dito sa last, no, sa right side. Yan, no? So ito na yung shear natin at yung bending moment. So it requires practice, no? How do we do the shear and moment diagram? You have to analyze the relationship, no? Yung kanilang mga relasyon, yung pagkakonekta nila, yung applied load sa shear force tsaka sa bending moment, no? So may ano yan, no? Merong mga relasyon yan. Yung applied load mo sa shear, which is V, no? Vertical shear, upward, downward, and bending moment, no? Papunta sa clockwise, which is negative, and here positive, no? So yan ang mangyayari, no? Ngayon, mag-ano pa tayo ng isang example na para mas malinaw bago tayo kasi malapit na rin yung time. Meron tayong isang beam na ganito, no? Anong tawag dito sa beam na ganito? When a beam is supported only on one side. Anong tawag?
Nakalimutan namin, sir.
Di ba ito yung beam, no? Isa lang, no? So, halimbawa, isa lang yung beam. Di ba cantilever? Tama ba?
Yes po, sir.
Bira, nung Merkulis lang, nakalimutan na agad. No? So, cantilever, no? Tignan nyo. So, ito ay supported on only one side. And of course, yung mga load nandito, no? Pwedeng sa dulo, pwede dyan, no? If only one side, it is cantilever, no? Mga pinangalan na yan ng tao nung matagal na. So, we go now to the cantilever. If it's supported on the left side, we know na meron siyang reaction, no? Vertical, horizontal, at meron din siyang moment, no? Ito. Meron din siyang moment, no? So horizontal is this at A, reactionary is this. And then magkakaroon din siyang moment, no? Ngayon, meron daw siyang force, no? Meron siyang force dito ng moment na binigay, no? Moment ibig sabihin pwede siyang mag-rotate 120 kilonewton meter. And then there are some loads given, no? Anong tawag niyo sa load ng ganito? Anong tawag sa load na ganyan? Pare-pareho, pero nakadistribute within the span of the distance na 3 meters. Anong tawag dyan? Yan ay, ano?
Uniform distributed load, sir.
Oh, the uniform distributed load. Kasi nga uniform, no? Ano yung hindi uniform? Pag naging triangle yan, no? Halimbawa, dito, 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 no? Mas mataas yung banda ron, no? Hindi siya uniform. Pero yan, pare-pareho ang nangyayari, ang mga load, kaya nga ang tawag dyan ay uniformly distributed load. Anong masabi nyo sa uniformly distributed load? Yung load na to, pwede pala natin gawin yan concentrated load, no? So, ibig sabihin, this distributed load, ang pangalan ay uniformly distributed load kasi pare-pareho yan, pwede natin gawin siyang concentrated load. Saan siya nakakoncentrate? Halimbawa, 3 meters ang ano niya, there's a 3 meters distance. Saan siya nakakoncentrate? Saan? Sa kaliwa, sa kanan, o sa gitna?
Sa lahat po, sir.
Pag ginawa nating concentrated, so sa gitna, no? So etong mga forces na to, pwede siyang maging isa, no? Pero nasa centroid. Okay? So magkakaroon ka ng isang force na lang na 6 kilonewton for every meter pero nasa centroid siya. Ano yung centroid ng 3 meters?
1.5.
1.5 meters. So all you have to do is to multiply the distance now to the centroid, no, from the reference papunta sa centroid, tapos multiply mo ng magnitude ng force. So ilan to? 1.5 meter times 6 kilonewton. Ilan yan? Per meter. So meron tayong 1.5 meter, no? Bawat meter is 6 kilonewton. So cancel yung meter. 6 times 5. 6 times 1.5. 6 times 1, then 6 times 0.5. Ilan?
9 po.
6 plus 3 equals 9. No? So ibig sabihin, sa gitna nitong 3 meters, at the center of the 3 meter span, we have 9 kilonewton. No? So naging ang uniformly distributed naging 9 kilonewtons, no? So yun ang mangyayari, no? Ito yun. So same thing, anong same thing? Anong first? To analyze the structure, FBD, free body diagram, meaning yung mga forces, no, tsaka yung mga reactionary forces dahil sa kanyang support, no? So meron dito, tapos may moment diyan. Ito may moment na, given naman to, no? Ngayon ito yung sinasabi natin, di ba kanina? Ito yun, no? 6 kilonewton for every meter, and then meron tayong meron tayong concentrated na 6, di ba? So eto. Kung gusto mong makuha lang yung dito, no? Pag gusto mong makuha dito, ito yung i-consider, no? Gawin mo siyang concentrated load, no? So ibig sabihin, ito 6 times 3, 18, no? 6 times 3, summation of forces vertical, 6 times 3 is 18. Summation, moment naman, 120, nasaan yun? Ito yun. 120, di ba? 120 yung kilonewton meter, tapos 6. Ito yun. 6 times 3, then ano pa? 5, ano to? 5 times 5. Saan ang galing yun? 5 times 5, no? Ano pa ba yung ibang given dyan? No? So meron siyang kinonsider na 5 na distance, no? Na 5 na distance times 5, no? So we will see that dito sa mga susunod, no? So 2 2 3 1, no? So ang pinag-uusapan natin dito is yung moment tsaka yung shear, no? So how much is this, no? 18. Paano natin nakuha yung 18? Siyempre nag-summation of forces tayo, di ba? So with respect to A, no? So ito 'yon, no? 6 times 3 is is 18, no? So yun yung ating nakuha na force, no? 6 times 3 is 18. So dito merong nagre-react na 18, no? So ito yun, going up, tapos uniform siya, di ba? 18 to eh. 18, no? So ayan yun, 18. Bago siya makarating doon sa susunod na load. Ang susunod na load naman natin ay moment, no? Moment at this, no? Sa 2 meters. So ito yon. So meron tayong 18, tapos dito naman moment. No? Paano naman natin ipapakita yung ating moment, no? Bending moment diagram. So we can have this, no? So yung sa free body kanina, ito yon, di ba? 18, tapos meron tayong magkakaroon tayo ng moment na kinumpute. Ito yon. Tapos ito yung 18 na reactionary, no? Reactionary dito, vertical shear, going up. Ito naman, going down. Sa moment naman, ito, 21. So, magkakaroon tayo ng 21, no? Kasi yung internal, no? Ito yung internal forces should match the external, no? So, kung may ano rito, meron tayo dito na moment, dapat mabalance niya yung moment doon sa kabila, no? Sa 21 kilonewton meter ang binanggit na moment dito, no? Pag kinumpute natin with respect to the distance, no? So yaan, no? So 21, ito 'yon, no? May 21 tayong moment. Tapos yun, bago siya makarating dito sa susunod, no? So magkakaroon tayo ng 57, no? Magkakaroon tayo ng 57 diyan, no? Pag kinumpute natin yung mga moment, no? So as we move along, ito yan, no? So ito magiging 63, no? Katulad ng ginawa natin kanina, magkakat lang tayo. Then ito naman, no? Magpapatuloy tayo. Ikakat natin in between, no? In between the next forces. So 27, no? Ito 'yon. So ito 'yon, 21, 57, 63, tapos 27. Ito yung nangyayari diyan, no? So ito yung mga division 2, 2, tapos ito, no, ginawa nating concentrated load. Ito 'yon, no, 6. So pwede tayong mag-summation ng mga forces diyan tsaka moment para makuha natin, no, katulad ng ginawa natin kanina sa first example. So if we already computed this, no, magkakaroon tayo dito halimbawa ng walang load na dito eh, no? Pag nakita niyo dito sa bandang dulo yung 1, tingnan niyo yung 1 class. Meron pa kayo nakitang load sa 1? 1 meter. Meron bang load? Wala naman, di ba?
Wala po.
Kasi ang concentration lang ng ano ito eh, 'di ba, yung 6 hanggang dito lang. So dito wala nang load kaya ito flat. Walang slope, no? Wala siyang rectangle. Ito naman pababa sa 0. 0 yung kasi yung force na. Ito naman pag ganun, tapos 0 na rin. Kaya pag nakakita kayo ng line with respect to the reference, no, ito naka-inline, 0 yan, no? 0 moment at 0 shear, no? Kasi wala namang ano diyan eh, force na, no? So yan ang magiging ano natin, ang magiging diagram natin, no? So dapat alam nyo kung paano nyo kukunin to. Di ba na-solve natin yung isang example kanina, no? Maglalagay tayo ng arbitrary distance x, tapos ibabalance natin, no? Para magkaroon tayo ng mga solve na unknown, no? So lalabas 'yan. So importante lang sa atin, we should be able to know how to draw the shear and bending moment diagram. On the pag drawing natin, ito 'yon, no, yung ito yung beam natin, no, class. Ito yung beam natin, pag dinraw mo sa mga nangyayaring forces, no? Halimbawa, ito, beam sag, aning sag, no? Yung pababa. Tapos ito naman hog, no? Yung sag ganito, 'di ba? Nagsag, lumaylay. Ito naman naghag. So ito 'yon, no? So ito yung ano niya, itsura. Pero ito yung sa moment diagram. Pakituloy na lang dito class, no? May sample dito, pakiaral na lang, no? Para sa Lunes trust naman tayo, no? Kasi we have to complete, no? May sample dito, ito, 10.2. Paki-check yung 10.2, nandiyan naman yung lahat, inisa-isa kung paano nakukuha. Ayan, no? So we will run here, no? We run over with this thing sa Lunes, sandali lang, no? Kung paano nakukuha yung shear. Ano yung shear natin? Anong letter yung shear? Vertical shear, V, no? Sana yun? Ito, no? So, ito yung shear natin, V. Ito yung moment. Kaya nga, meron tayong shear and moment diagram, no? So, VM. Ito yun, no? VM, 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 no? So, makukompute natin dyan yung progress, no? Tingnan nyo. 10 point, ano ba yun? 10.1 ba yun? Sabi ko sa inyo. So, yung 10 point, saan ba tayo nag-start? Yung pinapaaral ko sa inyo. 10.2 na ba? 10.2? Wala bang teto? Ayan, 10.2, no? So, aralin yung 10.2 class. Eto, nandito naman isa-isa, no? Paano nangyari to, no? 10.2, paano yung calculation, ilagay sa papel, no? Ilagay sa papel, kamerahan. Maliwanag ba? Yun yung ating homework. Kokopyahin na lang, ha? Pero pag kinopya nyo, nakadetalye. Wag eto, no? Kasi hindi ko na kailangan to. Nasa PowerPoint na to, eh. Ang kailangan ko is yung paano nakuha yung, eto class, oh. Ano to? 26, 26, 26, 26, no? 50, 50, 50, 50. Saan nakuha yan? Eto, aaralin nyo to. Kung paano nag-progress. Ito, this one. Okay? Ilagay sa papel. Sulat kamay, ha? Sulat kamay ang kailangan ko. Problem 10.2 at 10.3. Okay? Yun lang. Detalye. Okay?
Okay po, sir. Thank you po.
Maraming salamat at magandang hapon. Yun lang muna, ha? Have a good lunch.
Okay po.
Okay,
Thank you po. Thank you po.
Okay. Sa Lunes, ha? Isubmit na lang sa ano ko, sa email, sa UE email ko. Paki-submit na lang para doon na lang lahat, ha? Para madaling checkan. Sulat kamay, nakakamera, detalye, no? Kung paano nakuha yung moment at kung paano nakuha yung mga shear. At i-drawing ang, eto na, naka-drawing na eh, i-redraw na lang. Kasi gusto ko i-redraw nyo para matanim sa memory ng isip natin, no? Yung pictorial, no? Pictorial para ma-review natin sa isip natin. Okay? Maliwanag ba? 10 point. Oh.
Hanggang kailan po pwede magpasa, sir?
Ano?
Hanggang kailan po pwedeng ipasa?
Pwedeng ipasa hanggang linggo ng gabi. Okay lang?
Thank you po, sir.
Kasi para
Okay po, sir.
kasi nilalagay ko na counted
Salamat po.
counted to as quiz, ha? Quiz. Kasi hindi na tayo makapag-quiz, eh. Wala na tayong time, no? So, gawin nyo to, sulat kamay, tapos ika-count ko to as quiz, no? Tapos sa Lunes, trust tayo. Kailan tayo mag-exam? Friday? Gusto nyo ba Friday na lang?
Next week naman, sir.
Next week na Friday, pwede naman.
O sige, Friday na lang next week, ha? Kasi Biyernes naman ngayon, eh, no?
Friday, sir.
O, next week Friday. Hanggang Friday na lang kasi. Hanggang next week yung mga exam. O, sige. Salamat at magandang hapon, no?
Thank you.
Hanggang linggo na lang. Hanggang linggo to. Sige. Thank you very much and ingat kayo.
Hanggang linggo, sir.
Linggo ng gabi. Pakopyahin na lang, ha?
Sige po,
I-detalye lang, no? Baka hindi nyo pa magawa. Nandito na lahat. O, sige. Salamat.
Sige po, sir. Salamat
Thank
po.
you. Good afternoon.